our attention to, I want to turn our attention to the first example that we did on Friday. It was this right here, I believe. Was it that? Let me double check. Let me double check that. Yeah, it was that. Okay. So, look at how, if you look at the screen, look at how I graphed the vertical asymptotes. -2, 2, look at these blue dotted lines. Okay, look at those blue dotted lines with -2, 2. Okay. -2, 2. Now, for the horizontal asymptotes, y equals to 3. Look at this red dotted line right here. Okay. Now, when you have, just so there's not too much confusion here, let me go ahead and see if I can group this, group that. Okay, perfect. When you have, so I have in black, I have the x-axis and the y-axis. Okay. In blue, I have the vertical asymptotes, and in red, I have the horizontal asymptotes. Okay. Now, I want to give you some possibilities as to how the graph may look like. Okay. So again, you can cheat and use Desmos, but the whole point of this is to be able to graph it without using Desmos. Okay. So here are some possibilities. It may look like this. Okay, over here, because remember, it has to obey the asymptotes. It may look like this on the left side. Okay, I'm going to call this whole thing right here zone 1. Okay, this is going to be zone 1. Okay, so those are options for zone 1. Okay, now I'm going to call this zone 3. Okay, or excuse me, zone 2. And this is going to be zone 3. Okay, so that's a possibility for zone 1. Here's some possibilities for zone 3. Same idea. Okay, whoops. All right. So those are possibilities for zone 1 and 3. Okay. Here's a possibility for zone 2. Okay. Now check this out. For zone 2, this is even a possibility right here. You can even do this. Okay, it might look something like this, or the other way around. Okay. Now, these are a little bit less intuitive. Like you're saying, you might say, Mr. Chen, how come they can cross the horizontal asymptote in this case? That's a really good question. Okay, I don't know if you remember, but I told you when I was teaching you Haas that for Vaz, let's start with the Vaz, nothing can ever cross Vaz. Okay, but with Haas, as long as at least one piece obeys the Haas, it works. Okay, so if you look at zone 1 obeys the Haas, so all other zones can break the Haas. Okay. In this case, zone 1 and zone 3 obeys the Haas, so everything else, aka zone 2, can break the Haas. Okay. So it can look, so again, going back to zone 2, it can look like the blacks, or it can look like the reds. Okay. We're going to have to find out. Okay. So I'm just giving you possibilities. into what it may look like so that you can just get used to predicting what it might look like. Okay, so let's go ahead and go back to the other slide. Okay, now if we go back here, in zone 1, okay, this is where I want you to use your graphing calculator. So take out your graphing calculator. Okay, so if you look at zone 1, okay, which is the yellow highlight right here, zone 1, you have a vertical asymptote of -2. Okay, so what are some x values in zone 1? What are some easy x values in zone 1? Okay, because you have a vertical asymptote of -2, I would say, and I think you would agree with me, that -3, -4, -5 are x values that are in zone 1. Again, let me say that. -3, -4, -5 are x values that are in zone 1. Okay. All right. So we're basically going to plug in -3, -4, -5 into the equation and see what y values it spits out. So that's what zone 1 is going to be. Okay, so -3, -4, -5. Okay. So let's go ahead and do that. I want everyone right now to go ahead and put this into your calculator. 3x squared over x squared minus 4. Go ahead and put that in your calculator. And we're not going to use the trace function today. Okay, I'm going to show you a cool way of doing it. It's using the table function. Okay, so I would put it in like how you see it in with black parentheses. That's how I would do it. Look at the black parentheses I have. That's how I would put it into the calculator. Okay, I'll give you a second to put that in. Okay, now when you're done putting that in, I want everyone to press I want you to press second window. Okay, second window's on the top left. Okay, you're gonna press second window to access table set. Okay, and then I want you to scroll down to where it says independent. Okay, and press and have it on ask. Okay, and dependent, have it on auto. Okay, so again, after inputting the equation on y equals 2, the function on y equals 2, I should say, press second window, and then for independent, put ask, for dependent, put auto. And then go ahead and press second graph. Graph is on the top right to access table. Okay. And now you can start inputting values for x. So I'm going to input -3 and then press enter. And I get 5.4. I'm going to input -4. I'm going to press enter and I get 4. And I'm going to input -5, press enter, and I get 3.57. Okay. Do you guys understand how I got these yellow points here for zone 1? Yes or no? Let me phrase it this way. If you don't understand how I got those yellow points, message me right now. Okay? We're just literally plugging each x coordinate into our calculator and having our calculator spit out the y coordinate. That's it. Okay? Independent. Independent is ask, and dependent is auto. Okay? The calculator part, you put the function into your calculator. I'm going to explain it again. Okay? You put the calculator part into, the function into the calculator, and then you press second window to access table set. Independent is ask, dependent is auto. And then that's pretty much it. And then you just press second graph. Graph is on the top right to access table set, to access table, sorry. And then just start inputting these yellow highlights. Just start inputting these yellow highlights for x coordinates, and it'll spit out your y coordinates. That's it. That makes it so the calculator asks you what to input. It waits for your input before it spits out y. If you have it on auto, it's gonna automatically populate and create a table for you. You don't want to create a table. You want the calculator to ask for your input so they can spit out an output. X, exactly. That's exactly right. That's exactly right. Okay. -3, -4, -5. Someone asked, how did I get these specific x values? The reason is because you want to see what happens in zone 1. So we have a vertical asymptote of -2. What's some x coordinates in zone 1? That is to the left of -2. It's -3, -4, -5. Okay. All right. Now we're gonna do so. Now I'm gonna plot these points. Okay. I'm gonna plot these yellow points. Okay. I'm gonna turn my yellow highlights into purple. Okay. I'm gonna plot these purple highlights. Boom, boom, boom. Whoops. Boom, boom, boom. And purple is right here also. I'm gonna plot these purple points right here. Okay. And once I have these three points, I mean, you can plot more if you want. You can plot 100 points if you want. But once we get these three, we pretty much know that the graph is going to be this. The graph on zone 1 is going to be this top portion. Okay. In my other example, it was right here. It's going to be this portion right here. Okay. We narrowed it down to that portion. Now, like I said, if you want more assurance, you can plot more points. But 3 pretty much gives us the general gist of where it's located and how it's shaped. Okay. Let's do the same thing for zone 3. Okay. So let's bounce on over to zone 3 right here. So I'm going to move this right here. Okay. Now zone 3, same idea. We have a vertical asymptote of +2. Zone 3 is to the right of this vertical asymptote. So what are some x coordinates to the right of this what are some x coordinates to the right of this vertical asymptote of 2, +3, +4, +5? Okay. And then again, you just use the same thing. You just do the same thing. You don't have to go back to doing second window again and do the independent ask, dependent auto, because that's all you only need to do that once. You can go straight to second graph and table and just input 3, input 4, input 5, and it will spit out these right here, okay, those y coordinates. And then you graph it, and once again, just through graphing those 3 points, you get an idea of the location and shape of what happens in zone 3, which is basically this, okay? Same thing right here. It's basically that, okay? So we basically did zone 1 and zone 3 using 3 points and some common sense, okay, and some common sense mathematical reasoning, okay? Now let's look at zone 2, okay? Zone 2, okay? If we have vertical asymptotes right here, okay, of -2, 2, some easy ones that we can use is -1, 0, -1. Excuse me, -1, 0, +1. Okay, so whoops. So that's how I got, okay, that's how I got this. And then again, you don't need to go back to second window table set and do the independent ask dependent auto because we already did that the first time around. Go straight to second graph table and plug in -1, 0, 1, and it'll spit out these y coordinates. You plot those points and you get again the idea of the location and shape of this graph in the zone 2. Okay, and that's basically it. So just now we were doing zone 2, okay? Once you once you graph each zone, you're pretty much done, okay? So as of right now, our graph looks like the yellow highlight for each zone. Boom, boom, and boom. Okay? I just put this baby blue thing right here, this baby blue thing, just to let you know that it can look like that too. Okay? All right? So right now, I want you to do the same thing for 2M and 3M, okay? You're going to be you're going to set up zones and pick some x coordinates for each zones. Okay, some really easy ones, the easiest ones. Pick at least 3. Okay, I would pick at least 3, and then put it in your calculator and have your calculator take input from you for x and have it spit out y values for you, and just literally, I want this for your 2 problems that you did for homework. That's all I want. And then just graph it. Okay, and then just graph it right here. So I need these 2 things today. All right.